Hello students, welcome to another lecture on engineering mechanics. Today we will discuss two topics, resultant of force system and methods of determination of resultant of force system. So let us start the lecture. First of all, we will talk about resultant of a force system. The resultant of a force system is the single force which has same effect on the body as the given force system. Suppose there is a body, and on that body, let us say five forces are acting. So those five forces are forming a force system. And let us say because of those five forces, the body is moving with an acceleration of 5 meter per second square in horizontal direction. So if we can reduce that force system into a single force which can produce same effect on the body, that is, it can move the body with an acceleration of 5 meter per second square towards horizontal, then we will call that single force as the resultant of the force system. Now we'll see determination of resultant of coplanar concurrent force system. So in our syllabus, we will deal with coplanar concurrent force systems only. And I hope you are familiar with this system because we have discussed these systems in the previous lecture. So first of all, we will talk about two concurrent forces. Means we have two forces which are coplanar, means which are in the same plane, and they are meeting at a common point. So they have a point of concurrency, and we will see how to determine the resultant of such a force system. We can find the resultant of such a force system with the help of two methods. First method is known as Parallelogram Law of Forces. Second method is known as Triangle Law of Forces. Now we will see these two one by one. Let us first see Parallelogram Law of Forces. We have discussed this in brief in introductory lecture as well. So now today we will discuss it in detail. Let us first see its definition. The law of parallelogram of forces states that if two vectors acting on a particle at the same time be represented in a magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, their resultant vector is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Let us understand this through an example. Suppose there is one body, and on this body, two forces are acting. One is labeled as F1 and it is acting in horizontal direction, and second force is labeled as F2 and it is acting at some angle to the horizontal. Now let us draw their line of action. So when we will draw their line of action, we will find that their line of action are meeting at a common point. And these two forces are in the same plane, so they are forming a force system which is a coplanar and concurrent force system. So in order to find their resultant, we will apply parallelogram law of forces. So under this law, what we will do, we will arrange these two forces in such a manner that they are starting from a common point and they are acting as two adjacent sides of the parallelogram. Let us see how. So let us say the angle of this particular force is theta with the horizontal. Now we will apply a law of transmissibility over here, in which what we can do, we can shift the point of application of this force from this point to the point of concurrency, and we can shift the point of application of this force from this point to the point of concurrency. Means we can shift this vector from this point to this point, and we can shift this vector from this point of application to point of concurrency. So we have already learned that if we will do this according to law of transmissibility, then there will be no change in the system. The net effect will remain same. Okay, so this I will represent over here. Now I have drawn one force, that is the first force F1, and I have labeled it as OB. This vector is labeled as OB, where O is the point of concurrency. Now from the same point, I will draw the second vector and I will maintain its angle with the horizontal. Now you can see we have arranged these two forces in such a manner that they are acting at the same point and they are forming coplanar concurrent force system, and this we have done with the help of law of transmissibility. Now what we will do, we can represent these two forces as two adjacent sides of a parallelogram. For that we have to complete the parallelogram. So how we will complete? We will draw this vector over here and this vector from the tip of the first vector, and we will maintain their orientation. So if we will do this, then we will get the parallelogram. So the name of the parallelogram is OACB. Now if we sketch the longer diagonal of this parallelogram, which is starting from the same point at which both the forces are acting, then that particular diagonal will be represented as resultant of these two forces. So this is what we have learned from this definition. And the angle which the resultant makes with any of these force is labeled as alpha. Now we will discuss few more points. 2 points are to be carefully noted in this construction. The resultant is given by the diagonal OC passing through the point of intersection of the forces and not by the diagonal AB. Yes, this is very important point to understand. When we apply parallelogram law, we must see that we have to consider that diagonal of the parallelogram as a resultant of the two forces, which is starting from the same point at which these two forces are acting. Means we will consider OC as their resultant. We cannot consider AB as their resultant. Next point is the sense of the resultant force is from O to C. Yes, of course, the resultant will act from O to C. So these 2 points we should keep in our mind. From parallelogram law, we derive 2 formulas. First gives us the magnitude of the resultant of the force system. Second formula gives us the direction of the resultant of force system, where alpha is the angle which resultant makes with a particular force. Now there is one very important point to understand in this formula. When we solve any numerical, in the numerical we will be given about the magnitude of these two forces. There will be no F1 and F2. Like over here in this formula, F1 and F2 are mentioned. Fine. So over here also F1 and F2 are mentioned. So you can easily detect that in the denominator I have to put the magnitude of this particular force, and in the denominator I have to multiply the magnitude of this force with cos theta. But when you will solve some numericals, in the numericals you will be given these two values as numerical values. Let us say F1 is 10 Newton and F2 is 20 Newton. Then in that case you may get confused that which force I should take as F2 and which force I should take as F1. So let me give you a very simple rule for this. Suppose we are given this as 10 Newton and this force as 20 Newton. Remember, if you are taking angle of resultant with 10 Newton force, then you have to represent other force which is 20 Newton in the denominator. So in that case 20 Newton will become F2. Fine. But if we are considering angle of resultant with 20 Newton force, then the other force, which is 10 Newton, will become F2 and F1 will be 20 Newton. So very simple thing to understand, that the force with which we are considering the angle of resultant, which is alpha, then that force you have to consider as F1 and other force will be considered as F2. Now next we will talk about triangle law of forces. So let us first see the definition. Triangle law of forces states that if two forces acting at a point are represented in a magnitude and direction by the two adjacent sides of a triangle taken in order, then the closing side of the triangle taken in the reversed order represents the resultant of the forces in magnitude and direction. Let us understand this law through an example. So let us take the same example. We have a body and on this body two forces are acting. One is labeled as F1 and it is acting in horizontal direction. Another one is labeled as F2 and let us say it is acting at an angle of theta with F1. Now let us apply the triangle law of forces on this system in order to find the resultant of this force system. So let us see how to apply the triangle law of forces. First of all, we have to pick any one force out of these two. It is our choice. So let us pick this particular force and draw that force with same magnitude and direction. So see over here we have drawn that force with same magnitude and direction. Let us label it as OB. Then from the tip of this particular force we will start the second force and for that force we will maintain its magnitude and its direction. So you can see we have drawn the second force from the tip of the first force taken by us. So let us represent its angle with that force and we will represent its name as well. So name of second force vector is BC. Then triangle law says that if you will do this, then the closing side of this triangle will be the resultant of these two forces. So let us draw the closing side. You can see we have closed the triangle with another vector. So this is the resultant R of these two forces. And let us say it makes angle alpha with force F1. And let us say we have angle phi with force F2 and the resultant. Now from triangle law of forces we get one formula. It is shown over here. So let us understand this formula. See the first part. Over here F1, that is first force, is divided by sine phi. Now let us concentrate on this angle. This angle is in between the other two forces. The other two forces in the system are R and F2. So F1 is divided by sine of the angle between other two forces. This is equal to F2. F2 is divided by the sine of angle between other two forces, and between other two forces angle is alpha. Then this is equal to R divided by sine of angle between other two forces. So for R, other two forces are F1 and F2. Between these two forces angle is theta. So this formula is very useful in order to find the resultant of two concurrent coplanar force system. Next we will talk about composition of forces. The process of finding out the resultant force of a number of given forces is called the composition or compounding of forces. Let us understand this through an example. Suppose we have coplanar concurrent force system in which there are two forces and we want to find the resultant of these two forces. So if we can reduce this system into a single force which has the same effect as that of these two forces, then we'll call that as composition of forces. Now you can see we have replaced those two forces by a single force which has the same effect on the body as that of other two forces. So this process will be called as composition of forces. Now this we can illustrate with the help of triangle law, which we have just understood in the previous slide. Now you can see over here, so we have represented the closing side of the triangle as the resultant of these two forces. Or in other words, we can say we have composed these two forces into a single force. So for this particular force, these two are the components. Next we will talk about resolution of a force. The process of substituting a force by its components so that the net effect on the body remains the same is known as resolution of a force. Let us understand this through an example. So it is exactly opposite of composition of forces. Suppose we have a single force acting on a body, and let us say it is producing some effect on the body. Now if we can replace this force by other two forces which can produce same effect as that of this single force, then we can say that this process is a resolution of this particular force. We have resolved this force into its components which have the same effect as that of this particular force. So again, if we will consider the example of triangle law, we can say that this particular force is resolved into its components. Now we'll solve one example on parallelogram law of forces. So let us read the statement. The two forces P and Q act on a bolt A. Determine their resultant. So over here, one bolt is given, it is marked as A. On this bolt, two forces are acting. One is labeled as 40 Newton and second is labeled as 60 Newton. And both are acting at the same point. It means this is a coplanar concurrent force system. Now, if we want to apply parallelogram law on this particular system to find its resultant, then we have to use the formulas. So what are those formulas? The first formula is related to the magnitude of the resultant. So let us apply this particular formula. So in this case, P is 40 Newton, Q is 60 Newton. So let us put these values and take the square of the first force, that is P, take the square of second force, that is Q, then put the value of P and Q over here as 40 into 60. And what is theta over here? Theta is the angle between the two forces. This you should remember, that whenever we are applying this formula for parallelogram law of forces, then theta over here is representing the angle between the two concurrent forces. So angle between the two forces over here is 25. So that is why you can see 25 is taken. So when you will solve this, you will get the answer for resultant as 97.72 newtons. Now we will talk about the direction of resultant also. So formula for that is tan alpha is equal to f2 sin theta divided by f1 plus f2 cos theta, that we have already learned. So if we want to find alpha, we have to take tan inverse of f2 sin theta divided by f1 plus f2 cos theta. So let us put the values. Now again question arises, which force I should take F2? Fine. So if we are considering angle with 40 Newton force, then the other force, which is 60 Newton, will be considered as F2. Fine. Over here it is directly mentioned as Q. So this is F2 sin theta plus F1 plus F2 cos theta. So you can see we have entered the value of 60 Newton in the denominator. So that means we are considering this angle alpha with 40 Newton force. This we have already learned when we discussed the theory of parallelogram law of forces. So from here we will get an angle of 15.03 degrees. So this angle of resultant is with 40 Newton force because in the denominator we have considered the other force. Fine. This should keep in your mind while solving the problems on parallelogram law of forces.